We look up at the night sky, a canvas of infinite possibilities, and see Mars, a tiny reddish spark, a beacon in the darkness. It's a world that has captured our imagination for generations, fueling dreams of exploration and discovery. SpaceX, under the ambitious leadership of Elon Musk, has promised nothing less than a city on Mars, a fully self-sustaining civilization, a testament to human ingenuity and resilience. This bold vision represents humanity's leap to becoming a multi-planetary species, securing our future among the stars. But behind the official story, behind the carefully crafted press releases, there are whispers, leaked documents, hushed conversations among engineers, and glimpses into a reality far more complex than we've been led to believe. These fragments reveal a far more detailed and daring plan, a roadmap to Mars that goes beyond mere survival. The blueprints are no longer just dreams sketched on a whiteboard. They're filled with intricate details, complex calculations, and meticulously planned timelines, a testament to years of dedicated work. Landing zones are chosen not just for their safety, but for their strategic value, their potential resources, not just flatness, but the promise of what lies beneath the red dust. The first habitats? Not the inflatable domes we might expect, but the starships themselves, ingeniously repurposed as Martian homes, providing immediate shelter and a vital link to Earth. This is a planetary-scale bootstrap operation, a monumental undertaking built on innovation and resourcefulness. The leaked plans show granular strategies, meticulously crafted approaches for long-term settlement, for building a thriving community, not just mere survival against the odds. The real story is one of grit, unwavering risk assessment, and relentless iteration, learning from failures, anticipating them, expecting them, and building anyway, pushing the boundaries of what's possible. The first missions are one way: cargo, the essential building blocks of a new world; robots, the tireless workers preparing the ground for human arrival; and eventually, people, the pioneers who will shape the future of humanity on another planet. These pioneers will be the foundation of something bigger, a new chapter in the human story. These first inhabitants will be the most isolated humans in history, separated from Earth by unimaginable distances, facing a world not meant for them, a harsh and unforgiving environment that will test their limits. The scale is staggering, a project of unprecedented ambition, and the details only highlight the audacity, the sheer boldness of this cosmic endeavor. So, let's pull back the curtain, let's delve into the hidden depths of these plans, and dive into the nuts and bolts, the intricate engineering of this cosmic venture. What do these plans reveal about our future? What kind of society are we hoping to build on Mars? How will SpaceX keep humans alive, productive, and sane, providing the necessities for life and fostering a sense of community 140 million miles from home? How will they overcome the psychological challenges of isolation and confinement? This isn't just about rockets. It's not just about the technology, it's about us, about the very essence of what it means to be human. It's about our innate drive to explore, to push the boundaries of the known, to solve seemingly impossible problems, to overcome challenges that have daunted us for centuries, and to shape our destiny in the cosmos, to write a new chapter in the grand story of life. The journey to Mars begins not with a launch, not with the roar of engines and the fiery ascent, but with a plan, a meticulously crafted strategy that encompasses every aspect of this incredible undertaking. And that plan, as these leaked documents reveal, is far more incredible, far more ambitious than we ever imagined. Why Mars? The question echoes through the halls of space agencies and the dreams of future generations. Of all the worlds in our solar system, each a unique and fascinating sphere, Mars is the only realistic candidate for a second home. It beckons us with a promise of possibility. Venus is a hellscape, a world shrouded in toxic clouds and unbearable heat, and the outer planets are too far and inhospitable. They are majestic giants, but not suitable for human habitation. Mars is close enough to reach, a journey within our grasp, yet different enough to challenge us, to push the boundaries of our ingenuity. A Martian day is almost the same as Earth's, a familiar rhythm in an alien landscape, making it easier for humans and plants to adapt. This synchronization is a crucial advantage for establishing a sustainable presence. Mars has seasons, thanks to its axial tilt, a cycle of change that mirrors our own, which helps with agriculture and planning. These predictable shifts allow for strategic cultivation and resource management. Its thin, carbon dioxide-rich atmosphere offers some radiation protection, a fragile shield against the harsh realities of space, and could be thickened over centuries, a long-term project to transform the planet into a more habitable world. But the real prize is water, the lifeblood of civilization, locked as ice in the soil and polar caps. A vast reservoir waiting to be tapped. Water is essential, the cornerstone of survival for drinking, growing food, sustaining life in an alien environment, and splitting into hydrogen and oxygen. A versatile resource with multiple applications. Oxygen is for breathing, a fundamental requirement for human existence. Hydrogen and oxygen together make rocket fuel, powering our journey further into the cosmos. Mars could become a refueling station for deeper space exploration, a crucial stepping stone for voyages to other planets and beyond. In situ resource utilization, using what's already there, minimizing reliance on Earth, is the key to unlocking the solar system, a pathway to self-sufficiency and expansion. Mars isn't a random target, it's not just a destination, it's a strategic choice, a calculated move in the grand game of space exploration. It has sunlight, carbon dioxide, and water ice, the raw materials for a new civilization, the basics for life and industry, the foundation upon which we can build a future among the stars. The challenges are immense, the obstacles are significant: thin air, cold, radiation, a hostile environment that demands innovation and resilience. But Mars offers a foothold, a place to begin, a fighting chance, an opportunity to prove our capabilities and expand our horizons. It's the closest thing we have to a second Earth, our best hope for ensuring the long-term survival of humanity, a place where humanity can plant a new seed, a chance to start anew, and see if it grows, to nurture a new branch of the human family on the red planet. To reach Mars, a monumental leap for humanity, requires more than just a conventional rocket. It demands a completely new approach to space travel. You need Starship, SpaceX's fully reusable spacecraft, a marvel of engineering designed to revolutionize access to space. Starship represents a paradigm shift in space exploration. It's a massive stainless steel ship, a testament to innovative design, engineered to carry over 100 tons of cargo. That's enough to transport vital supplies, equipment, or even 100 people to Mars, paving the way for a permanent human presence. Its secret lies in rapid reusability, a key factor in making interplanetary travel economically viable. It's designed to operate like an airliner, capable of multiple flights, not a disposable rocket meant for a single journey. The Super Heavy booster provides the initial thrust, launching Starship beyond Earth's atmosphere. The booster then returns to Earth for a controlled landing, ready for its next mission. Once in orbit, Starship is refueled, a crucial step for extending its range and enabling the long voyage to Mars. Fully fueled, it embarks on its interplanetary trajectory, heading towards the red planet. This reusable architecture dramatically reduces the cost of spaceflight, making ambitious projects like Mars colonization a tangible reality. The journey itself is a long one, taking approximately 6 to 9 months. During this time, the colonists will live and work within Starship's spacious, pressurized interior. The ship is equipped with comfortable cabins, common areas for socializing and recreation, and even hydroponic gardens to grow fresh produce, providing a sustainable food source. Advanced life support systems, robust radiation shielding, and dedicated exercise areas are essential for maintaining the crew's health and well-being. These features are crucial for mitigating the challenges of long-duration spaceflight and ensuring the crew arrives on Mars in optimal condition. Upon arrival at Mars, Starship executes a dramatic belly flop maneuver to enter the Martian atmosphere. It uses its aerodynamic body and fins to control its descent and slow down, acting as a giant air brake. Finally, it reignites its engines for a precise, engine-powered touchdown on the Martian surface. The first starships to arrive on Mars won't be making a return trip to Earth. Instead, they'll be repurposed, becoming the very first Martian buildings, providing shelter and resources for the initial colonists. They'll be transformed into essential infrastructure, including power stations, factories for producing vital materials, and comfortable homes. The Interplanetary Ark, having served its purpose, becomes the foundation of a new settlement. This incredible journey is just the beginning of humanity's expansion into the solar system, a bold step towards becoming an interplanetary species. Landing is just the start, the real challenge is staying. SpaceX's plan is to live off the land using in-situ resource utilization as the colony's foundation. First priorities: power and water. Solar panels deployed and cleaned by robots will power everything. Rovers will mine ice-rich soil, extracting water for drinking, hygiene, and greenhouses. Water is also split into hydrogen and oxygen for breathing. hydrogen for making methane fuel with carbon dioxide from the air. This fuel powers Starship's engines, enabling return trips and closing the loop. With power, water, and fuel secured, the focus shifts to permanent habitats. Martian regolith, surface soil, will be used to build structures likely underground or covered for radiation protection. Robots and 3D printers will construct these habitats, forming the seeds of the first Martian city, a city built from Mars itself. Life on Mars will be relentless work and routine. Every colonist is a multi-skilled technician, geologist, farmer, engineer. The colony's survival depends on everyone's effort. There are no passengers. Days start with health checks and briefings, then split between outdoor tasks, inspecting equipment, collecting samples, and indoor work, monitoring life support, tending crops. Greenhouses are vital for food and morale, a splash of green in a red world. Communication with Earth is delayed, recreation is digital, and community is everything. Life on Mars is a grind, but it's a grind with purpose, ensuring humanity's survival on a new world. The path to Mars is filled with immense challenges, great filters that could halt the mission. Starship's complexity from launch to landing is a series of potential failures. Radiation is a constant threat. Habitats must be shielded underground or with Martian soil. The human element is unpredictable, extreme isolation and stress test even the best crews. SpaceX is focusing on psychological resilience and teamwork in crew selection. Mars's gravity, toxic soil and unknown biology pose risks to health and agriculture. We must avoid contaminating Mars with Earth microbes and be ready for the possibility of Martian life. These are not just engineering problems, but fundamental questions about life adapting to a new world. We stand on the edge of a new era. The colonization of Mars is more than an engineering feat. It's a shift in the human story. Becoming multiplanetary is the ultimate backup plan, and the innovations needed for Mars will help us on Earth. Closed-loop life support, sustainable tech, and new perspectives could make us better stewards of our home planet. But there are ethical questions. Who goes, who governs? The first colony may be a company town, but true independence will be a grand experiment. The first Martians will be founders of a new civilization. Our drive to explore is ancient. We push boundaries, we are restless. Mars is not the end, but the beginning of a new chapter. The next giant leap for humankind is onto the red soil of Mars.